Unit 4. The main objective of Unit 4 is architectural choices and performance trade-off involved in designing and realizing the circuits in CMOS technology are discussed. From the fourth unit, we are going to see the memory architecture. So, from the memory architecture, there is a read-write memory, non-volatile read-write memory. So, in read-write memory, we have telling that a volatile memory only. So volatile memory mainly it has a whenever the power is on, all the data it should be stored. If the power is not functioning, the data is not stored there. So say for an example, random access. Here there are two types, SRAM and DRAM. So this fully it can store whenever the power is on. Non-volatile read-write memory, it is a EEPROM, E2PROM and flash. Here there is no need of the power here, so it will be automatically stored whenever the power is on or off condition, like that. So read-only memory, it is a mask programmable PROM. So large portion of silicon area is dedicated to the storage of data and program instructions. So here the data has to be stored and then the program instructions are here designed. So we are telling that one example for that volatile and non-volatile, it is a best example of the memory architecture. Next we are going to discuss about classified and the basic parameters of memory architecture. First one, size. Second one, timing parameters, functions, access pattern, input output architecture, and finally the applications. The first parameters we are going to discuss about the size. In the memory architecture, the chip designer expresses the size in bytes. Say for kilobyte, gigabyte, megabyte. So we can tell it that a size, how many size of memory you are using in a particular chip. So we have to tell that as a kilobyte, gigabyte and megabyte. The system designer expresses the storage requirement in terms of words. A 32-bit register can store 2 power 32 different values. The next one, timing parameters. So if we are using a read-only memory, only that read access only follows in that particular memory. Say for example, random access memory, the read-write operation is performed and during the power on, how the data is going to be stored there. So that and all we are going to discuss about in this timing parameters. Here the read cycle, it is to whenever the data is going to be used means you are going to store means it is to access, and whenever the data, the correct data has stored or not, if you are going to access for read, then it will be used for read operation. The third parameter is a function parameter. In the function parameter, we having a ROM, RAM. From the RAM, we are having a two classification: static memory, dynamic memory. So, and then a non-volatile memory, we have a EEPROM and EEPROM. We have used that. This is a main function. And then an access pattern, how the memory has access all the data. If random access memory means whenever the power is on, the data will be stored. If the power is off means the data will be off. That means it cannot be stored there. And then the condition is either that it is going to be stored as a LIFO or FIFO. FIFO is a first in first out operation, and LIFO is a last in first out operation. So these are the access pattern we have used there. So video memories are example of this class. In video processing, data is acquired and output serially. Content access memory, also called the associative memory, uses a word of data itself as input in a query style format. And the next parameter, input output architecture. Semiconductor memories are classified based on the number of data input and output ports. Most of the memory single port, that is shared for both input and outputs. Memories are higher bandwidth requirement have multiple input and output ports. Example for this, RISC microprocessor. RISC is in the sense reduced instruction set computing. And finally the parameters is a application. Most large size memories are packed as a standalone IC. Here the following types of memory architectures is n-word memory architecture, array structured memory architecture, hierarchical memory architecture, content addressable memory architecture. Thank you.